you kidding me? That's how this works? Hey guys, this is Patrick from STH. That might be one of the craziest things you've ever seen, but don't let it fool you, because this Gigabyte G242-P32 server is perhaps the most important server that you are going to see this year. And I'm saying that even knowing that we are gonna have Intel Sapphire Rapids and also AMD Genoa in the next quarter or so. So I know that those are coming, but at the same time, this is the server that I think might be the most important for the industry. And I'm gonna show you why in this video. But the quick answer is super simple. This is not an Intel server, and it's not an AMD EPYC server. Instead, this is an Ampere Altra server, which means that it's actually using an ARM processor, using the ARM Neoverse N1 cores. And then we also have something that's not just an ARM server, but we also have an NVIDIA GPU. And you might be sitting there saying, Patrick, I've seen an ARM CPU with an NVIDIA GPU that's called Jetson. I've seen that many times. What's so different about this? Well, the NVIDIA GPUs that we have here are actually the 80 gigabyte NVIDIA A100 PCIe. So the server that we're gonna look at is basically the NVIDIA HPC, so ARM and NVIDIA GPU HPC dev kit. I had to put it together, so there's definitely some differences that we're gonna talk about, but I wanted to do a little piece on this because I think it's super interesting. And we should probably talk about how this even came to be, because I wasn't originally gonna do this for the STH main site. It was definitely not gonna be an STH YouTube video, but then basically what happened was we got a server, and the server came in because the idea was that I was gonna do a GTC session on this exact solution. So Gigabyte sponsored that session, but then I was like sitting there, I'm like, well, I still have the hardware here, so why don't we just go show everybody? Because I think that this is super interesting. So Gigabyte is not sponsoring this video, we're doing this ourselves, but they did sponsor the GTC session, and that's the reason we actually have this. But I think it's so cool that, like I just said, we have to go and show you guys. So that's exactly what we're gonna do today. And the reason that this is super important is because this is not a low power Jetson device. It's also not a Raspberry Pi. I mean, think about all the people that go and do Raspberry Pi, they do ARM development on Raspberry Pis, and then, what do you do to scale up? How do you go to a server model? Well, one option is you can go to AWS and use Graviton 3, and of course you can go do that, but the other option is that you can use one of the other cloud providers. And if you use Microsoft Azure, Oracle Cloud, if you use Google Cloud and you use their ARM server offerings, you're going to be using an Ampere Altra processor. Now that Ampere Altra is the one that we reviewed back in 2020 on the STH main site, but what I have here and what we put in this server is the Ampere Altra Max. The big difference is that although this is still using the Neoverse N1 cores, this is also clocked at 3 gigahertz, but it has 128 cores. The previous one that we saw with the Ampere Altra was only an 80 core unit, and the 80 core units I think are what actually like Oracle Cloud uses. I think some of the other cloud providers only use the 64 core versions. So this is basically like 2 of the cloud provider CPUs all in only one CPU. Also Graviton 3 is a 64 core CPU, and this is 128 cores, not threads, or not just threads, but cores. So if you're looking to scale up your design out of a Raspberry Pi, what you could do is you could try to figure out how to put a whole bunch of them together and then figure out how to like jerry rig some, I don't know, GPUs onto that or something like that. But that's kind of crazy. So of course you wouldn't go do that. Instead, what you would do is you'd use something like an NVIDIA Jetson Orin. Oh, and we're gonna be doing a piece on this pretty darn soon. But this is actually a Jetson Orin, and this has an Ampere generation GPU. It has ARM cores that are definitely a lot faster than Raspberry Pi cores. It has much memory, all that kind of stuff. So this is a pretty high-end unit, but I think these things are like, this dev kit is like $2,000 or something like that. So it's pretty darn expensive. And also it's not really something that, is a good form factor for like deploying in a data center. This is good for like edge and maybe doing like robotics projects, but not really putting in a data center. And also you don't have that many cores. You don't have like 80 cores or 128 cores, right? So that is why these things are super important. That's what we're looking at today. Now this Gigabyte server is super exciting, and we're gonna go through all the hardware in a little bit, but I just wanna say like, what the heck and why is this thing here? So NVIDIA has been transitioning, like that Jetson I just showed, has been transitioning to a model where they're really using more ARM CPUs. We talked about the NVIDIA Jetson Orin, but they also have things like the ITX platform, which is gonna be for like medical and like healthcare and stuff like that. There's also the various drive platforms for automotive that NVIDIA has. NVIDIA has ARM platforms like their DPUs, and they're gonna be integrating DPUs with GPUs in the future all on a single card. And so there's that. And then in 2023, we're gonna have the NVIDIA Grace and Grace Hopper. And the Grace Hopper is basically gonna be a giant H100 along with a 72 core ARM Neoverse V2, cores. Like, I mean, this is gonna be like an amazing, really cool product. And we're gonna have more on that, of course, when it gets launched. But this is definitely the way that NVIDIA is going. Like, let's just call it what it is. And so Gigabyte actually makes this really cool development platform. This is the official NVIDIA development platform if you're gonna be doing HPC on ARM. Well, NVIDIA HPC on ARM. I guess if you're doing AMD, you're gonna do something different. Okay, so let's get to the hardware because it's awesome. So on the front of the system, what you're gonna see is that this is a 2U server. Now on the bottom, what you have is 4 hot swap bays. These 4 hot swap bays are either SAS or SATA. We're gonna get into how that all works in a little bit, but you can put either ones there, and the 2 options that you can basically put, you can put a 3.5-inch hard drive in there, or you can put SSDs. Now, stock, I think the development platform actually comes with like a 6 terabyte hard drive, but frankly, I didn't have anything that small, so we put an 18 terabyte drive and it worked no problem. You can also use SAS and SATA SSDs, so we actually put SSDs in here because, well, that's kind of how we run all of our stuff anyway. So we just put SSDs because I think that's a little bit more practical these days. And so you have 4 bays to go do that. Now, the reason that we only have 4 bays is because a lot of this chassis is actually built for airflow. And that's what we have above those 3.5-inch drives. Now, the first thing you notice when you look inside the system is definitely the fact that there are 4 spots that you could put GPUs. Now, this particular server is only gonna have 2 GPUs, and that's what comes in the HPC dev kit. And what you will see is that the other risers that look like they are GPU risers, they actually don't have the little PCIe risers in them, and there's only 2 spots that you can really put GPUs. So those are what we're gonna be using for our NVIDIA A100s. And the configuration that's the official configuration is that we have 1 GPU that's in front of the other. So we have one in this kind of front section where there are 3 GPUs, and then there's another GPU behind it. And so we'll be installing that in a little bit. And since we are doing the server review, I do want to point out that these risers are actually kind of cool because they are the more modern design where the riser has a data and a power cable that are going into it. And that allows you to have a little bit more flexibility. It actually makes these things quite a bit easier to install in a lot of cases. Now, behind those 3 front GPUs, what you get is 4 fans. Now, I have to say, I don't really love these fans. And the reason I don't really love these fans is that you can kind of swap them out, but they're not in like really nice hot swap, like slick hot swap carriers that some other Gigabyte servers have. And it just kind of feels like this is more of a development platform, maybe because of that. But you know, that actually is what this is. So we're gonna say that it works, and it's worked fine for us. So that's okay, but I just kind of wish that in a future generation, Gigabyte actually went and put you know, kind of more robust fans in this. Now, behind those 4 fans, first thing we'll see is we're just gonna call out that there are 2 M.2 slots really for boot SSDs, and we didn't use them, but they're there. And the other feature that's really easy on the storage side is that you're going to see that there is a Broadcom SAS 3008 card that's actually there. It's just kind of a standard HBA. It's a Gigabyte version, but it's a standard, you know, Broadcom SAS chip that you would see in basically most of the vendors would have something like this. But the big thing here is that this is working in an ARM server, so we were able to go run a standard Broadcom SAS adapter in an ARM server. This is a huge, very good thing. Okay, so let's get to that fun one that we opened this with, and that's this this back area. Now, what you're gonna see is that there are like power supplies, but the CPU and like some of the memory, like that's underneath, and so couldn't figure out how to get into it. And then all of a sudden, I lifted the power supplies, and this whole little thing actually lifts up, and you're able to get inside of it. And that's just, to me, is just totally crazy that that's even a thing. It's a different way to go do it. I don't know if I love it, but it's super interesting, and so okay. And you'll see in some of these that we have with the system where it's on its side, you can actually swing this out, and it does lock. So if you are gonna go and, for example, install the Ampere Altra Max because it wasn't installed for you by Gigabyte or another or somebody else, this actually stays up so it doesn't just keep like flopping down and hitting you. So you actually have to unlock it to be able to put it back down. But underneath there, what you get is a couple of really cool things. First, you get the CPU socket. You also get the DIMM slots, and we have a total of 16 DIMM slots. The Ampere Ultra and Ultra Max have 8 channel of DDR4 3200, and you can do 2 DIMMs per channel, which gives you these 16 slots. So this has the full memory configuration possible here. The other thing that you'll see real quick is that there is an OCP NIC 2.0 slot. Frankly, I have no idea why we didn't put one in, but it's there, and if you wanted to, you could put one in. So taking a look at the rear IO for a second, what you're gonna see is a pretty standard, just kind of server IO. It's a little different because of this kind of funky chassis configuration, but what we see is we have a management port, we have 3 USB ports, we also have serial, and we have VGA. The other thing that we have is we have dual 1 gigabit Ethernet ports. So you think like, oh, this is like a super advanced server. Do you have fast networking? The answer on the motherboard is no. These are really kind of more of like out-of-band managements of like, you know, you're running an OS or something like that. This would kind of be like your management ports that you would use for that, and then your applications you would go run on higher speed NICs. I will just note that the actual system itself comes with single port DPUs, so NVIDIA BlueField 2 DPUs. The challenge that we had was that the ones that we have a bunch of, and we have like, I think over a dozen of these now, is we actually have the dual port, so dual 100 gig port BlueField 2 DPUs, but these are full height cards, so they don't fit in the low profile slots of this chassis, which kind of stinks, right? Because like, you know, there's all those spots for the GPU GPUs and all that kind of stuff, and we can't put a full height DPU in there. I don't know. I kind of wish that was different, but that is what it is. And if you do get the HPC developer kit, you do get the right DPUs. We just we're building this ourselves, so we didn't have those. So one of the fun things is that I actually got to install the Ampere Altra Max in this. Now I think standard the HPC dev kit has a Ampere Altra, so the 80 core model, but we had the 128 core model and we had the 80 cores too. But I was kind of like, why would we put the 80 core one in when we could put the 128 core one in? So obviously we should go do that, and that's exactly what we did. This installation, by the way, is quite a bit harder than both AMD and Intel at this point. I actually have an installation video for if you want to do Cooper Lake or Ice Lake. We have an installation video on that you can find on YouTube. Like, this thing is super scary. You're supposed to use suction cups, but I didn't have the right suction cups, so I just kind of installed it by hand. I've done this before, and I've done it a couple times, so I felt confident in it. But definitely, I would tell almost everybody, please, please, please go get these installed at the factory. Don't do it yourself, because this is a pretty complex mechanism, and it's definitely a little bit harder than what you would see from Intel or AMD. Now, in terms of memory, I mentioned that we have 16 DIMM slots, but we're only going to be using 512 gigs, so a half a terabyte of memory, which is not a lot. It's actually how much I use in just my primary Threadripper per workstation these days, so it's not necessarily like a huge amount of memory. But on the other hand, you know, that's I think what the actual dev kit came with, and it just so happens that we had 8 64 gig DIMMs just sitting around, so those went in. You can of course put more memory, we just didn't do that. I will of course note that you use ECC RDIMMs and LRDIMMs. Some folks don't know this, but you can use ECC memory, and you do use ECC memory, and we literally are using the exact same DIMMs that we used in our Xeon and our EPYC servers in the lab. We literally took those same memory, DDR4 3200 RDIMMs, we took them out of a server, and we put them back in this one. I just want to show you that installing those GPUs was super easy because we have these risers. It took only a few seconds and they're pretty easy to install. These are also the NVIDIA A100 80 gigabyte ones. So these are the 300 watt TDP, very high-end GPUs that you can get. So it was really cool that we are able to use those really high-end GPUs with this ARM server platform. Now the power supplies are 1.6 kilowatt units. And something that was kind of cool about these is the fact that you can use them not just at like 200 to 240 volts, you can go all the way down to 100 volts. And the reason that's important is that a lot of folks will buy this kind of server or this class of server, and they'll use it either for like AI development or HPC development. You know, so it is nice that for a lot of folks that are still on 110, 120 volt power because they're in a, you know, North American office or something like that, you can actually go power this. It's not crazy loud. We don't usually do noise on servers because you're supposed to be in data centers. But at the same time, this actually wasn't too bad. I've definitely heard a lot louder GPU servers, but it's also not something that I would prefer to have in my office. And the 1.6 kilowatts I think is actually a pretty good number. Even when we had this all loaded up with everything, I don't think we really peaked much above like 1.2 kilowatts. So in terms of power consumption, I think that this thing wasn't too bad, and the 1.6 kilowatts was perfectly fine. Now, all this hardware is absolutely great. But the next question, of course, is like, well, can you use it? How bad is the experience? Like, is this like a dev platform because the platform sucks? Or is this a dev platform because, you know, it needs a little bit of last mile work? I know that ARM platforms in the past have been painful. In fact, I think it was me and like Johan, we were the two that did the Cavium ThunderX1. So, you know, back in the old days when that was the big platform, it was actually Gigabyte, both single socket and dual socket platforms that we used. But that was like the big thing. And then we had ThunderX2 and actually spoke at the ThunderX2 launch. You know, that was still Cavium right before Marvell bought them. And, you know, I spoke at that launch and it was a lot better, but it was still, you know, those are still very, very rough. So I guess a lot of people ask, like, you know, how bad is the experience with an ARM server these days? And I'm just going to show you guys. So one of the things that you get is you actually get IPMI management interface. So you can just log in like you would a, you know, AMD or Intel server from Gigabyte. You have a web management interface. And the other thing you have is you have an HTML5 IKVM. Something that you couldn't do previously, or at least reliably previously, was actually to go and install an OS using an image and just kind of loading it over IPMI. That didn't always work, guys. Like this installing Ubuntu is a big deal. And so I said, oh, well, why don't I just go do that? And I ran through the installer and it worked just kind of like an x86 or an AMD EPYC server. It was super easy to go do. And just to kind of give you an idea of how easy this is, guys, I just went to ubuntu.com. I went to the AMD, so the ARM64 image. I just downloaded the ISO of 22.04 242-P32 server, and I just literally loaded up on the IPMI interface, got on the HTML5 IKVM, and I just am literally doing this. And just to show you like how far this has come, and this to me is like the thing that is just crazy, is the fact that while we're going through the installer, it even shows things like, hey, you have NVIDIA GPUs. Do you want to go put the NVIDIA driver on while you're installing this? Like guys, this used to be, like just to even get to that point where you could start installing an NVIDIA driver like 3-4 years ago was a total pain in the butt. Like that's just all we're gonna say. It was very difficult to go do. And now it's just a part of the installer process. Other big things that you're gonna wanna do, of course, when you set up a system, like you would do on an x86 system, most people are just gonna install Docker, at least as like kind of like a first step. And you totally can just go install Docker and NVIDIA Docker. It works, you know, just how you normally would do it. Now, most people are just gonna either use package managers or install scripts or something like that. And basically this worked no problem. It was super easy, just kind of almost the same way that you would do it on an AMD or an Intel x86 system. This was super easy to go set up, took a couple minutes and ready to go. The other thing that you might wanna do though is that NVIDIA has an HPC SDK and toolset that they use and they have available that you can actually go download from the NVIDIA website. And so if you want to go do that, you totally can. We actually did install it on this and it did work no problem. And what a lot of people do these days when you get an NVIDIA powered server is you might go to NGC, and that's NVIDIA's container solution that you can just go download containers that they maintain with different applications already that are, you know, set up to be NVIDIA optimized and you know, basically run containers out of the box, doing useful things without having to spend a lot of time setting up environments. So that's something that a lot of people use, is just NGC containers. Now, things that you're gonna look for there is ARM64 and also multi-architecture containers, because those are the ones that you can run out of the box on this super easy. An example is if you wanna go run TensorFlow and do AI inferencing, you can literally just download the container and start working immediately. It's super easy to go do it. But I have to warn you that not every container that NVIDIA has, no matter what they say, we still found a bunch of them that didn't actually have ARM versions. A good example was when we're recording this video. It may have changed by the time this actually goes live, but as we're recording this video, like Morpheus is an example where, you know, I remember sitting through the announcement of Morpheus, and that does not have an ARM version on NGC. So just kind of saying that, you know, it may be different now, but when we were looking, it didn't. And so not all images will have the ARM64 or multi-architecture at this point, but at some point, I think that NVIDIA is working to have everything work on these ARM platforms. So I think that that's something that is gonna start going away over time. Now, I do wanna say real quick here that a lot of the ARM folks are gonna just tell you that, hey, like everything just works, it's great, and nothing goes wrong. A lot of stuff works, but not everything. And where you really kind of feel this, or at least I feel this when I was using this system, as you're kind of going through your notes and, you know, you're just kind of like, a lot of people do what I do and just have like scripts or have notes of things and, you know, copy paste from there. And when you do that, you often find that like dependencies sometimes aren't ARM ready or like something like that. And then you have to spend a little bit of time either compiling something or, you know, trying to find a dependency or something like that. And that's why this is a development platform, not just development to just get things to work, but then also the optimization work that's behind it. There's a lot of money going behind it and a lot of effort these days, but at the same time, there is a big difference between this ARM platform and also an AMD or Intel platform. If you just want to just start and get everything to work and just copy and paste things off of the internet, I know that we shouldn't be telling people to do that, but that's like, you know, what a lot of people do, right? Is go find a guide on the internet and copy paste things when they don't work. And so, you know, just that experience, just frankly, is a lot better on Intel and AMD than it is on ARM at this point. And that's why this is a development platform. There's still work that has to happen. Okay, let's just talk about performance here. Of course, the HPC server wants to know memory bandwidth. With GCC, you can pretty easily get to a little over 150 gigabytes per second, no problem. On Stream Triad, you can, of course, get higher with better optimizations, but I just want to kind of show you guys that it's actually pretty decent. You know, you get 8-channel memory, you have DDR4 3200, and because of that, you actually get pretty decent performance. We ran a couple of workloads, and we just kind of compared them to our x86 version, and you know, we did get, in some cases, actually pretty darn close, and NVIDIA shows numbers that are pretty close. There are things that, like, frankly, like if you run the exact same workload and you just kind of follow scripts, you're gonna see things like, you know, dependencies in there, it doesn't break, and it just breaks, and then you compile it and you don't get as good a performance. And that's kind of why this is a development platform, right? But let me up-level this whole thing for you, because we've been working with the Ampere ARM since like 2020. And I think I can kind of explain how to think about the Ultra Max. Now, newer cores and other types of processors are definitely different. But when I think about the Ultra Max, and I think about the Ampere Ultra, what I think about is that you have cores, and basically 2 cores is roughly equivalent to an AMD, EPYC 7003 Milan core with its SMT thread. So you get like 1 core, 2 threads on AMD, or you get 2 physical cores with ARM. And by the way, that's exactly the entire point of this. And the other little wrinkle is that this is the AMD EPYC 7773X, and this will be a little bit faster just because you have, like another ½ gigabyte of cache on this. So this one's actually faster because of that in a lot of workloads. The other thing though is like what the Ampere Altra is optimized for, right? The Ampere Altra architecture is really focused on integer performance, and that's, they can do floating point, sure, but the real focus of this is integer and also having all those cores and fairness among the cores. And what does that really mean? Well, a couple things here, right? So like, for example, things like having AVX2, AVX512, those are big accelerators. We've actually done some pieces on that. And so those, if you're doing like kind of like those floating point workloads, you're gonna see that AMD and Intel definitely talk about those all the time with their chips and talk about how they can do HPC. This is the HPC dev platform, so this is very important here. Whereas if you look at like the Ampere Altra and a lot of the marketing materials around a lot of the ARM processors, they really are focused on integer performance, and that's just kind of what they're good at. And there's definitely a reason for that, right? There are a lot of the cloud workloads, like if you're running like Nginx or Redis or like any of those kinds of things, they are optimized for ARM like crazy now, and they actually run really, really well on ARM architectures just because you have a lot of cores instead of threads. And so those kind of workloads do very well. But at the same time, on the current generation processors, you don't get things like BNNI on the Intel side as an example, where you get some acceleration for like AI, and that actually has some pretty decent performance. And also some of the things that we've done recently when we looked at like the QAT engine and stuff like that Intel has, that's kind of stuff. And I'm not talking about the hardware accelerator, by the way, if you didn't see the last video or one of the last videos, it's a big differentiation there. But that QAT engine also, can take advantage of some instructions that the Ampere guys just don't have because they, are not really focused on those kind of workloads. And so, I just kind of want to point out the fact that you're not really, it's very difficult nowadays to start comparing these kind of processors because the Ampere Altra Max is really, really good at like integer workloads. And the thought in a HPC platform is that you're actually offloading a lot of the floating point stuff to your GPU because you have this just giant honking GPU that has a higher TDP than your CPU. And so, that's really focused on doing your floating point and your AI stuff. And my last point is that with the Ampere Altra Max, you have to remember that you have like 3 gigahertz and you have ARM cores, and there are a lot of them, but what they're really designed to do is so like if you have cloud VMs and there are a whole bunch of different people on that chip, what you don't necessarily want to have happen is one customer gets a bad experience because you have another customer on there, right? So you're kind of always dealing with that kind of contention, and that's really what the Ampere guys were trying to solve. But the downside to that kind of model is that in the just kind of current chips that you can go buy, you're going to see that the single thread performance of a so you have a per core licensed software, that's much, much better on the AMD and Intel systems at this point. Those systems have much higher performance per core. So if you're running things like SQL Server or Oracle or one of those types of applications where you're paying per core license costs, you most likely want an AMD or an Intel CPU, not an ARM CPU at this point. So what is the impact of this? Because that's really what this is all about. Why do we even care about an ARM-based server from Gigabyte with NVIDIA GPUs and these Ultra Max processors? Why do we even care about that? And I think that the reason is pretty simple to see. Now, some folks will remember that NVIDIA tried buying ARM, and we have Bluefield 2 here, and we have the NVIDIA or Jetson Orin or AGX Orin here, and we also have the HPC dev kit with the Ampere Altra and then the NVIDIA A100 GPUs. NVIDIA just announced its IGX platform for things like healthcare, and that has ARM cores and NVIDIA GPUs. Also for their drive systems, they have NVIDIA GPUs with ARM CPU cores. So it's just kind of like when you look across the board, what you notice is the fact that NVIDIA is basically using ARM cores with its GPU cores everywhere. And that will become a big deal very soon when we get to NVIDIA Grace and Grace Hopper, where you have the Neoverse V2, so the much higher performance than what we have here, cores, plus you also have a GPU, and you have them all packaged together. That's gonna be something that's very different, and it's also definitely the way that NVIDIA is going. So NVIDIA right now is saying oh yeah, hey, we're gonna keep supporting Intel and AMD because frankly, that's where you get the best user experience these days. Let's call it what it is, especially in the data center. But in all the platforms that it's making now, NVIDIA is actually going and using ARM processors, right? It doesn't take a genius to kind of see where this is all going. So don't get me wrong. I definitely think that for the time being, if I were a CIO and you said hey, you have to go deploy today, you know, a new project and you have to go use NVIDIA GPUs, and you know, we also need to have some kind of CPU with that. What do we want? Do we want to use the Ultra or Ultra Max, or do we want to use like an AMD EPYC Milan, or you know, soon Genoa or Sapphire Rapids, or you know, Ice Lake or whatever? Like you know, in this next quarter, personally, I would still be doing x86 if I were going to do a large scale deployment. And the reason I would be doing that is just because, you know, frankly, more stuff works out of the box. This is still a development platform. Now, for folks like if you're Microsoft or you're Google or Oracle or like one of those guys, you can definitely go deploy the Ultra Max as much as you want. And there are definitely people that are going to want to, you know, develop on it, and you may just be able to get a market for that. But I think if you're just like running a company, personally, I'm a little bit risk adverse, so I would probably still use x86. But at the same time, I do think that this is super important because you can get a platform today that has a giant ARM CPU, giant GPUs, and you can use that platform to do development for all the really cool next-gen platforms that are coming up. And that's really the point of this Gigabyte G242 server. This is the development platform for the future of NVIDIA and ARM. So with that, I just want to say thank you to Gigabyte for sending the server and kind of arranging this. Also, you know, we got the NVIDIA GPUs, and then also Ampere for the Ultra Max. You know, that really made this possible. We had a whole bunch of parts that we just kind of threw in, and we were able to go and create a system that was really cool that we got to show you. So I'm super excited. Now I'm really excited to pretty soon get to show you this NVIDIA AGX Orin, if it hasn't already been posted already. And then the other thing is also just we have a ton of really cool servers with Sapphire Rapids and Genoa launching. I'm just super excited to get to show you guys everything. And this is just a fun time in server. So I hope you enjoy this. And if you did like this video, well, why don't you give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.